Hi everyone, my name is Lydia, and this is what I wish they taught me about econometrics and introduction. You've seen the theory, you've seen this in the R version. Now we're going to see everything in STATA. We've worked quite a lot with dummy variables and interaction variables, and in the previous video with working with interactions on STATA, we saw two different ways of working with them. So in this video now, we're going to complete this mini-series by also showing the full workflow on how we run the linear or the log interaction models, how to report the estimations. And keep in mind, this video will move a little bit faster since you've seen already most of the concepts. So without further ado, let's switch to STATA and see the actual code and the actual results for, again, we're using the same data set, so we're going to see different results based on the same data set. Resuming where we left off from the previous video, we ran for the dummy continuous case, we had a regression where we simply looked at the effect of the SAT score and whether being female or male had a different effect on your college GPA. We looked at the margins effect and also at the margins plot. And finally, we created this two-way graph to see the actual fitted lines. And although sometimes we shouldn't be trusting too much at the graph, we should be trusting more to the actual test. So for instance, in here, this test would have told us whether the variable, the interaction variable, is statistically significant or not. In this case, we could have seen it directly also by looking at the t-test here or the p-value of the interaction, and we would have come to the conclusion that this is statistically insignificant. Now we're going to move a little bit faster in here. We're going to see the continuous case and looking at the question, does high school percentile moderate the effect of SAT on GPA? So now we're going to use the double hashtag method, and as you remember, it was imperative that you indicate as data whether these variables are factors or dummies or continuous variables. Both SAT and the percentile are continuous variables, so we've included the C dot in the beginning. So if we run this regression, we should be seeing SAT and then the percentile separately, and finally the interaction here. We can calculate the marginal effect of the SAT at different values. Keep in mind, in this case, we have to pick some values ourselves. For instance, 10, 25, 50, 75, and 90th percentile. It's not exactly the same code as we had earlier for the dummy variable where you only had female equal to 0 and female equal to 1. So you just did margins at female and with respect to SAT. In this case in here, we're going to do, again, with the margins with respect to SAT, but we're picking these different values of the percentile. We can run the margins in here right after running the regression so that the betas are saved automatically, and then STATA can make those computations in the background. But as we can see, for all of the 5 different values in here, we've got these different numbers, which should be reflective of the fact that, yeah, the marginal effect should be different depending on the percentile value, because we know that the derivative at this case would have been beta 1 plus beta 3 times the percentile. Okay. We can also see the margins plot for this particular case. So simply at all of these different percentiles, we see the marginal effect. So it's just a graphical presentation, basically, of all of these numbers that we had in the table as well. Okay? Keep in mind, even in this case, simply looking at those, we wouldn't be very clear or sure about whether these are statistically significant or not. So normally in the actual regression in here, you should be looking at the p-values or the t-statistics to know whether they are statistically significant or not. Based on these results in here, it would seem that the interaction is statistically significant. So normally we could say that yes, we do see a difference in the effect of SAT on GPA at different high school percentiles, basically. On the log level interaction, again, I'm going to go a little bit faster on this one. We're doing exactly the same things as we did in the dummy continuous case, but now we're going to log the GPA, and nothing changes in terms of the syntax when we're doing the double hashtag in here. Just keep in mind, now SAT is continuous I dot female because we've got a dummy variable. And we can run exactly the same regression. Nothing should change. It's just the interpretation now that is going to change because you have a percentage effect, and you should be making that interpretation as a 1 unit increase in SAT changes now the GPA by the beta 1 plus beta 3 female times 1%. And you can see this effect in terms of percentage here by using the margins again. Normally you would need to also multiply this with 100 because keep in mind, it's a percentage. You can look also at the log-log interaction. Nothing again will change. You just need to recreate a log version of the SAT variable and simply run the regression as usual. Keep in mind, it's a continuous variable in this particular regression that we're running here. So when we look at the margins, again, we have to specify values for that. And the interpretation now is in elasticity, so we're going to say a 1% increase in SAT changes the GPA by beta 1 plus beta 3 times percentage. So in here, we're going to have like different numbers depending on the different level of the percentile that you have, okay? To have a look at like all the different models that we have been running so far, just like we did in R, we can see that in the case for the first model, linear, the interaction was actually insignificant, while it also in the log level was insignificant. We see that in the other model that we had in log-log, well, we used the percentile. Actually, we do find that the interaction turns to be statistically significant, okay? Keep in mind, things will change depending on the model, okay? So that's why it's always good to report the full model. Never forget to include any constituent terms. So even the summary in here is including obviously all of the variables. Keep in mind the 0.female in here is not, or 0.female and the interaction are not showing because that information would have been included already in the constant here. So these are sort of redundant lines that are appearing in STATA. And the beta 1s are never being reported alone, so you always need to report marginal effects, which you could have done with the margins to evaluate at meaningful values. You can test directly from these tables on the significance of beta 3, and this summary in here is making your life a little bit easier because what it's doing is like showing you stars wherever, like 3 stars wherever it's significance at the 1%, 2 stars, for instance, here when it's significance at the 10%, at the 5%, sorry, that would have been the opposite. So 3 stars when it's at the 1%, 2 stars at the 5%, 1 star would have been at the 10%, but wherever you have no stars, it means it's insignificant, okay? Keep in mind, this is also the kind of tables that sometimes you are asked to produce for your assignments, and this is the kind of tables, maybe a little bit more nicely edited for your dissertations. You'd have the typical coefficient here, the standard errors, and then the stars with the level of significance. Okay. So the only other thing is, again, the STATA workflow is very similar to the R workflow that we saw. The only difference being that now you have a few more tools that you didn't have in R. In interaction in STATA, you could have used two different ways. The most, or like the quickest one being the one with a double hashtag, which allows you also to use the margins and the margins plot commands. Okay. The margins and the margins plot, they simply turn your interaction models into more like clear and interpretable assignment ready or dissertation ready results. So keep in mind, these are very simple tools, but still very powerful because it gives you a very good overview of what's happening in your model. Very useful, especially if you're running a difference in difference kind of estimation, because the kind of code that you would be using would be very similar. That completes the interactions chapter. You now have the theory, the intuition, the math, the software tools to run and interpret any interaction model you encounter. And in the next video, we're going to move to more exciting econometrics topics. So stay tuned, and I'll see you in the next video.